But the problem, okay, with knowing the vertex form, quadratic formula, here it is, vertex form, quadratic formula, right? So knowing this guy doesn't help if you don't have a quadratic in vertex form. If your quadratic is not ax minus h squared plus k. So but many quadratics, often your quadratic will be in the more familiar form, ax squared, that's the standard form, plus bx plus c. So the question is, if we have a quadratic like this, we want to graph it, or we want to use this form to solve it? The trick is there an easy way to translate from from the standard form to vertex form? Well, what I'm going to do is I'm going to foil. I'm going to expand. I'm going to foil x minus h squared. So this is going to turn into a x minus h plus k, which in turn is going to turn into, so foil. So we'll start with the first. X times x is x squared. Then we'll have the outers, x times minus h, the inners, minus h times x, that's the same thing, so that's minus 2hx, and then the lasts, minus k times minus k is, minus h times minus h is h squared. Minus times minus turns into a plus k, and now I'm going to distribute the a. So this turns into a x squared minus 2ahx plus h squared plus a h squared plus k. So that's what happens when I expand out the vertex form. Now, the idea is we're going to match that up. Well, ax squared is the same in both forms. But in this form, we have minus 2ah, and in this form times x, and in this form we have b times x. So we can write, if there's the same quadratic, right? If h and k are the vertex of this guy, then b has to equal minus 2ah. That will make this quadratic and that quadratic have the same vertex, which means that the vertex of this quadratic will be, okay, so we're going to, actually, let's get out of that. Backwards. We're going to divide both sides by minus 2ah. Minus 2ah. And that gives me b divided by minus 2ah. Going to parenthesize, remember PEMDAS, right? Is minus 2, not minus 2ah, I did that wrong, minus 2a. Minus 2a. Minus 2a. So b over minus 2a is h. So that means that is the formula. Basically, if we have a quadratic, ax squared plus bx plus c, and we want to find h, that's the x value of the vertex. So this is the x value of the vertex, b over minus 2a. Now, if we want to find a y value for this quadratic, y value, well, this guy equals y. So I just need, so to get k, I just need to say k is a h squared, right, plus bh plus c. Of course, this guy, whenever we plug any x value into here, we get a y value. And k is the y value. So this is the y value of the vertex. Okay? And so, once I have those two values, I can just do, I can take this guy and that gives me the roots. So, let's say I want graphic, okay, so let's say I want to do graphically and algebraically. Only one C in algebraically. Come on, good. Here it goes. Find the roots of, okay, let's say -1 x squared plus 6x, okay, minus 4. Okay, so what am I going to do? To graph it or to do the algebra, I'm going to, right, so this is, we're just finding when it equals 0. Okay, I'm going to find h and k. So, I'm going to take, so we know a is -1, b is 6, and c is -4. So I'm going to do 6 divided by -2, parenthesize, very important, times -1 is going to give me 3, which is h. Now, all I have to do is plug that 3 into this formula, and I'll get k. So that's going to be -1 times 3 squared plus 6 times 3 minus 4, which is going to give me 5 for k. Okay, so if I want to solve it graphically, all I have to do is grab a piece of graph paper. Here's one. Okay. So drop that piece of graph paper right over here and get my face from on top of it. Come on, be good. Here it goes. And I'm going to see that this is a -1 x squared quadratic whose vertex is 3, 5. So what I'm going to do is grab my pen. Draw. let's see. Once again, this thing is getting in my way. Stop that. Move, 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 move. I need to use a mouse for a sec. I'm going to put myself down here now. Okay, so now I'm going to go there. And I'm going to get nice, thick blue dots. And yes, I know, it's working on the other movie. Okay, we're going to do nice, thick blue dots, starting at 3, 5. Oops, I can do better than that. Come on, 3, 5. There it is. Then I can go now. It's -1 times 1 squared, so I'm over 1, down 1, over 1, down 1. Now, -1 times 2 squared, -1 times 4, I go over 2, down 4, 2, 1. -1 times 3 squared, over 3, from the vertex, always from the vertex, down 9 to -4. The 3 down 9 to -4. That, by the way, is the C value. And that's the C value is always where it intersects the y-axis. Because when we plug 0, everything else disappears. We go over 4, down 16, and that takes us down 1 below the graph, like that. And then we can go like this. Let's see if I can do this nicely this time. So, this time, okay, if I read this graph right, here are the 2 roots. This one looks like 5.3, and that one looks basically like 0.7. It does. So that's graphically. So now let's attack it algebraically. Well, I have a formula now. Okay, so I just can plug in the formula. H, right? Let's just copy the formula again. Right? And we'll put in, oops. So I want it to come in. Copy the formula, you silly thing. Okay, so we have, let's see if it caught that this time. Yeah, h plus or minus the square root of minus k over a. Well, h is 3, and we'll start with minus the square root of minus 5 divided by minus 1. And that gives me 0.7, basically. At least within my ability to see this graph. Now, if we do 3 plus the square root of minus 5 divided by minus 1, that's going to give me 5.2, but that's close enough to 5.3. So you see how easy it is now to solve this. Much easier than using this complicated formula that everyone, well, not everyone, there are usually 1 or 2 students in the class who can pull it off, but most everyone manages to screw up one way or another. So, try solving some similar equations, like, let's say 2x minus 5 squared minus 7 equals 0, algebraically and graphically. Or say even minus 3. Oh, wait a second. I want it to be this, so I don't want that. The brain is not clicking in. 2x squared minus, that would be 20x. Okay. And then that would be plus. Okay. So 43. Okay, and that would, I'm just checking my work here. Yeah. And that, so let's solve for that guy equal to 0. And how about minus, let's try something really exotic, minus 3, x squared, okay, plus, okay, we'll make that minus, okay, it's 12x, okay, minus 7 equals 0. So try to solve those two guys graphically and algebraically. So that's a nice little problem there. I think that's enough for this video.